Hello friends, welcome to all. My name is P.B. Prajapati. I am lecturer in applied mechanics. I am in government polytechnic and I am teaching this subject since long. In the previous lectures we discussed about resolution and we can resolve along two orthogonal or perpendicular axis and along non-perpendicular axis. But by and large we use two mutually perpendicular axes in practice. So mostly you will have to involve in resolving the forces in two mutually perpendicular axes. And also we discuss about resultant, and we also see how we are getting resultant from the theory of resolution. So for that we also discuss about sigma fx and sigma fy, and also using that law of resolution we see that rx is equal to fx and ry is equal to sigma fy, and we can also see sigma fx for all forces acting on a point is say 0, and sigma fy is also 0, then force system is said to be in equilibrium. So we discuss about equilibrium, also we discuss about resultant and equilibrant. Today we will see some problems regarding resolution and equilibrium, and also about equilibrant. So see, you are given a problem like this. For related to equilibrant, say you are asked to find out equilibrant of three forces, 50 Newton, 10 Newton and 30 Newton acting from center of equilateral triangle towards the apex taken in order. So to solve this, first of all you will have to prepare a figure, then you can proceed. So from this data we can draw a figure like this. So this is equilateral triangle, that is all sides are equal, and three forces 10 Newton, 50 Newton and 30 Newton are acting through the CG of or center of the triangle towards apex. So we can show this force system as a concurrent force system like this. So here it is 10 Newton force, here it is 50 Newton force, and here it is 30 Newton force, and angle between all is equal. So we can see total angle between any two forces will be equal to 120, and with respect to horizontal axis we say angle of say this force can be taken as 30 degree, and also this angle as 30 degree with x-axis, and we can see this will be vertical. Now simplifying to find out the equilibrant force, we will simplify the figure. This given force system we can simplify like this, that is this 10 Newton force which is inclined need to be resolved along x and y. So along x its component would be 10 cos 30, and along y axis it will be 10 sin 30. Here 50 Newton force is totally acting in the y direction, upward direction, so its component along x would be 0. Then to resolve this 30 Newton force which is making angle 30 degree with the negative x-axis, we can resolve that force as along x 30 cos 30, because angle is with x-axis, so it's this is known as its adjacent component, so cos, and along y 30 sin 30. So on resolving forces along two orthogonal axes and simplifying it like this, we can proceed further finding the equilibrant force. So now solving using resolved components, that is all components we see, we have to do the algebraic sum. So here sigma fx, that is algebraic sum of all forces acting in x direction, and we will have to also consider sine. Otherwise say because we have taken angles separately with any axis, if it is taken with positive x-axis all angles, then this sign need not to be taken care. In that case it will be automatically taken care. So here we have taken angles separately with say either positive x-axis or negative x-axis, so it need sign convention for summarizing. So here sigma fx, we can do summation like this, that is components along x, and those are tan cos 30 acting towards right, so plus, minus 30 cos 30 acting towards left on the x-axis, so minus, and total of this on calculating gives values 17.32 Newton. Sigma fy, that is algebraic sum of all forces acting in the vertical direction, and considering sign as vertical up as positive, we can summarize as 50 minus 30 sin 30 and minus 10 sin 30. Simplifying or by calculating by means of calculator, it will give 30 Newton value. Then if you find resultant, R is equal to sigma fx square root of sigma fx square plus sigma fy square, so it will give 34.64 Newton. And its angle of the resultant force with positive x-axis is given by alpha r tan inverse sigma fy divided by sigma fx. So putting all values, tan inverse, this is sigma fy, that is 30 here from here, and sigma fx, that is 17.32. so this is coming minus 60 degree. Minus sign shows this angle is taken from x-axis in the clockwise direction. So as you know, resultant is a single force which gives the effect of all given forces, and equilibriant is nothing but equal in magnitude to the resultant force and opposite to the direction of resultant force. So here that resultant is, say, we can locate like this, result R, which is 34.64, and it is making angle 60 degree with negative x-axis. So our equilibriant force will be exactly equal to this resultant force but opposite in direction, means it will be in this direction. So here R is known as equilibriant force, and its magnitude will be exactly equal to 34.64, but you can see direction of equilibriant is exactly opposite to the R. So we can write that is, say, here resultant was making, say, it is making angle in the clockwise direction with positive x-axis, sorry, negative x-axis 60 degree, then equilibriant will be making angle 60 degree with respect to positive x-axis and in the clockwise direction. So this is how we can find resultant and its equilibriant. Now taking one more problem, say on equilibrium. So here, say you are given a point in equilibrium is pulled by 5 strings at equal angle. If tensions in 3 consecutive strings are 5 kN, 7 kN and 6 kN, and suppose you are asked to find tension in other 2 strings, then you will have to draw figure first having this data. So figure can be drawn like this. So here on the point O, say 5 forces like 5 kN, 7 kilonewton, 6 kN, and here 4th and 5th force, which are P and Q respectively, but they are unknown, their values are not given, and you are asked to find out P and Q. So here it will be easy to solve this problem taking all the angles with respect to positive x-axis and not separately either with positive axis or negative x-axis. So here for say considering this line of action of this force as positive x-axis, its angle with that axis will be 0. So angle of 5 kN force with positive x-axis is say 0, that is theta 1 is 0. Now for this force 7 kilonewton, angle will be 72 degree. So theta 2 here 72 degree. Then angle of 6 kilonewton force, mind well we are measuring all the angles from positive x-axis, so that theta 3 is given by 144 degree. Likewise for fourth force, that is P, angle is say theta 4 and it will be 288 degree, and angle of Q with positive x-axis will be equal to 360 minus 72, that is 270 odd. Okay, so here 360 minus 72 will give you the theta 5 value. Here now solving this problem, point O is in equilibrium, so whatever sum of all these forces along x must come equal to 0. So sigma fx is equal to 0 and sigma fy is equal to 0 because system is given in equilibrium. That is R means resultant of the forces is 0. So first of all we will find sigma fx and sigma fy, and then equating it with 0 we will get unknown forces. So here finding sigma fx we can say 5 cos 0, that is force into its cos component with respect to the angle. Then plus 7 cos 72 for the second force, third force 6 cos 144, then fourth force P cos 216 degree plus Q cos 288 degree, that is 360 minus 72 degree. So simplifying this, and this will be equal to 0. Now simplifying this we will get 0.81 minus 0.309 Q is equal to 2.313, and say this is equation 1. Now sigma fy, which is given by sine components, 5 sine 0 plus 7 sine 72 plus 6 sine 144 degree plus P cos 216, sorry it should be sine here, plus Q sine 244, sorry 288 degree. So here it is written wrong, it should be sine here and sine also here. So 0.587 P, simplifying this we will get 0.587 P plus 0.951 Q is equal to 10.19, and this is the equation 2. On solving equation 1 and 2, which is in the terms of unknown P and Q, we will get P is equal to 5.62 kilonewton and Q is equal to 7.25 kilonewton. So using the concept of equilibrium, we can find unknown forces for the non-concurrent force system, and for that we considered sigma fx, that is for equilibrium we consider sigma fx 0 and sigma fy also 0. Now next, suppose we are given the force system shown in figure is in equilibrium and you are asked to find out the unknown force. So here forces are 1, 2, 3, 4 and 5, and here unknown is P and its angle with negative x-axis is also unknown. So we can find unknown force P by means of concept of equilibrium, that is here again system is in equilibrium, so its sigma fx will be 0 and sigma fy is equal to 0. So what we will have to do, we will first of all simplify this figure, because angles we have taken separately with positive x-axis or negative x-axis or even with y. So we need resolution, and then we will do summation of summation of components along x and y considering sine. So here resolving all these forces, first of all see 100 kN force which is acting totally along x direction, so its component along x direction will be 100 totally, while here 60 kN force is making angles with positive x-axis, so its component will be 60 cos 45. So here angle is 45, so this component will be 60 cos 45, and vertical component would be 60 sine 45. I think here it is not shown, so it is remaining there. Then P, resolving this force P, so its component along x P cos theta and along y P sin theta, so it should be 60 sine 45 here. Then resolving this force 40 kilonewton, we will get components 40 sine 60 and 40 cos 60, because it is having angle with vertical, so vertical component would be cos and horizontal component would be sine. Then 80 kilonewton force which is totally acting in downward vertical direction, so it is given as 80 kilonewton full value. Now doing summation considering sine, sigma fx here considering sine towards right as plus, so if we do summations, then force 100 kilonewton, then 60 cos 45 positive x direction, and then in the negative x direction P cos theta, so that is it should be minus here, again it is mistaken there, and 40 sine 60, that is already minus, so it should be minus here. Then sigma fy, and considering vertical upward sine as plus, so in x direction we have this value as plus P sin theta minus 80 minus 40 cos 60, which is equal to 0. So we will get P sin theta is equal to 57.58 here, and in the condition sigma fx we got P cos theta is equal to this value. Okay, so on solving these two we will get P is equal to 122.25 kN, and theta will get 28.10. This is how we got dividing this equation by equation given here. So equation, say this is 2 and this is 1, so equation 2 divided by equation 1 will give you value of tan theta, and so first of all you will get theta here, tan theta value will be there, and theta will be equal to tan inverse of that value, and then putting that theta value anywhere in any equation we get P value which is 122.25 kN. So this is about problems related with equilibrium and equilibrant. Now we will see methods to find resultant force. As we discussed, we can find resultant in for forces. We can categorize, say single force is acting on a body, then that single force itself is a resultant. But we need to find resultant by any means when these type two cases are arising. Say two forces are given, then we need to find resultant by means available, and also in the case when more than two forces are given. So if two forces are given, two concurrent forces are given, we can solve that problem related to finding resultant force by analytical means and by graphical means. Analytical means we can find the solution of finding resultant force by means of resolution method that we discussed just now, and also by parallelogram law, and also by triangle law. So for two forces, these two are specific methods which can be used only when two concurrent forces are there, while resolution method we can use for two forces as well as more than two forces. So in that case also we can solve the problem by resolution method. So resolution method is common for any category or any number of forces given, while parallelogram law and triangle law is the specific methods for finding resultant of two concurrent forces only. These two methods we can't use for any forces except two concurrent forces. Then graphically we can also, for two concurrent forces, we can find the solution by graphical means, that is by drawing parallelogram, and also we can find resultant of two concurrent forces by drawing a triangle. This we will discuss in the coming lectures. While here, say, in the category of more than two forces, two concurrent forces, and you are asked to find out resultant, again we can say we can solve it by analytical means and by graphical means. Graphical means, analytical means, it involves some formulas or equations, while graphical means involves drawing certain figures, that is drawing points, lines, or any geometrical shapes, and we will get the resultant force. So analytically, as I discussed, for more than two forces also we can use resolution method, which is known as analytical, and in that method you are aware of that formula which is given for finding R. R is equal to, say, root of sigma fx square plus sigma fy square, and say more than two concurrent forces are given. To find its solution graphically, we can use polygon law, polygon method, or we can draw a polygon and we can find the resultant. Now, method of resolution. We already discussed about how forces can be resolved, and along x and y. So here it can be used to find resultant of two or more concurrent forces, as I discussed, and steps to find resultant by resolution method are given as below. So here, resolve all the forces. First step is to resolve all the forces. What we need is to resolve all the forces horizontally and find the algebraic sum of all the horizontal components, that is sigma fx, and also considering the sign. Then second step is to resolve all the forces vertically and find the algebraic sum of the vertical components, that is sigma fy. In that case you will have to find sigma fy. Then using this formula we can calculate resultant force R, which is equal to root of sigma fx square plus sigma fy square. Then say whenever you are asked to find out resultant force, means not only magnitude of that resultant, but also you also need to find its direction, that is angle. So generally we find the angle of resultant force with respect to positive x-axis. So it is given in terms of angle with positive x-axis. So here let, or say with x-axis. So here say let alpha r. Alpha r is given a symbol for angle of resultant. Here alpha is the angle and r means for resultant. So alpha r be the acute angles made by alpha with horizontal. So always the value of alpha r will come less than 90 degree. That's why it is known as acute angle. So here finding alpha r using this equation, tan inverse divided of sigma fy and divided by sigma fx. So alpha r is tan inverse of sigma fy divided by sigma fx. So this is what method of resolution is. Then we are also finding the resultant force, and sometimes you are asked to locate the resultant, and then in that case this table will be useful. So how to locate the resultant force? Say you are given, or say you are getting a sine of sigma fx, that is algebraic sum of all horizontal components. Say that value is coming plus, and same way say value of sigma fy, that is the vertical components, it is also coming plus. Then it decides the resultant force would be falling in the first quadrant. Say sine of sigma fx is minus and sigma fy is plus, then resultant would be falling in the second quadrant. Say sigma fx minus and sigma fy also minus, then the resultant will be falling in third quadrant. Say sine of sigma fx is plus and sine of sigma fy is minus, then it is coming in the fourth quadrant. So we can show here by means of quadrant. Say both sine plus, that is sigma fx plus sigma fy plus, then this is known as first quadrant. Okay. If sigma fx is minus and sigma fy is plus, then it is falling in the second quadrant, that is this quadrant. If both the values sigma fx and fy are minus, then it is falling in the third quadrant. And say sigma fx plus and sigma fy is minus, then it is falling in the fourth quadrant. This is how this is useful to locate the resultant force, that is in which quadrant the resultant force is existing. Then to find method of resolution for finding r. This is the method or one numerical problem for finding the resultant force by means of resolution. So as I remind you, we can find resultant of two concurrent forces by resolution method, by parallelogram method, by triangle law method. But here say we are solving this problem by resolution. So say problem is given like two concurrent forces, one along x direction and one is along this direction, 100 kN. So angle between these two is say 45. Then resolving this is in the say x direction. We consider this as a line of action of this force as x direction. Then this force will be making angle 45 degree with that axis. So here this force did not to be resolved, while this force is considered as inclined force and it need to be resolved. So resolving 100 kilonewton force along x, it will give 100 cos 45 value, while in the y direction it will have component 100 sin 45. While here this force is already in the x direction, which is 100 kN. Then finding sigma fx with this sign as plus, we can do summation along x direction, that is this. So here there are two forces, 100 kN and 100 cos 45. So with sign 100 will be plus and 100 cos 45 will be also plus, and that will give you the value 170.71 kilonewton. Then sigma fy, considering vertical upward sign as plus, here you can see in the y direction only one component, that is 100 sine 45, and it is also upward, so plus, so 100 sine 45, which is plus value, and its value is 70.71. Then finding resultant force using these two sigma fx and sigma fy values, which is given by r is equal to root of sigma fx square plus sigma fy square. So sigma fx in our case is 170.71, so square of that, plus sigma fy, that is 70.71, square of that, and finding the square root, we will have resultant force 184.77 kilonewton. So this gives you the value of resultant force. You also need to find out direction of that resultant force, that is alpha r, which is given by tan inverse sigma fy divided by sigma fx. So tan inverse sigma fy, which is 70.71, and sigma fx, which is 170.71. So simplifying this, we will get value 22.50, and this is mind well, it is giving value with respect to positive x-axis. Say it is positive, means it is measured with positive x-axis and in the anti-clockwise direction. Say this value is coming minus, then it will be with x-axis but in the clockwise direction. Say if you want to find out angle of resultant with respect to y-axis, then what you have to do here in this equation, you will have to write sigma fx divided by sigma fy. But usually we find angle with respect to positive x-axis, x-axis. So this can be always shown in the form of tan inverse sigma fy divided by sigma fx. Now solving more problems regarding finding the resultant of two concurrent forces by means of resolution. Suppose we are given two concurrent forces as 10 kN and 15 kN, but here angle between these two is not directly given, it is given in the form of this horizontal and vertical values of that inclined force. So here first of all you will have to find out angle which this force 15 Newton is making. So it can be calculated as tan theta, because considering this triangle here, say this is theta, then it will be given as tan theta, opposite sign, opposite value divided by adjacent value 1 by 1. So it is giving theta as 45. So first of all we are finding the angle of this force, then doing simplification of this figure, that is writing the components along x and y. So here 10 Newton force, we are considering line of action of this force as x-axis or horizontal axis. Its component will be 10 Newton itself, while this force is inclined and it is making 45-degree angle with this line. So its component would be 15 cos 45, and its component along y will be 15 sin 45. Then doing summation of all these components along x and along y separately. First of all, say along x sigma fx, and considering force or arrow towards right as plus, then it will have in the x direction this value and this value both plus. So 10 plus 15 cos 45. While in y direction doing summation, there is only one component, and considering this upward sign as plus, we will have 15 sin 45 plus value, and that is 10.61. Then putting values of sigma fx and sigma fy into this formula, we will get resultant force, its magnitude. So here root of sigma fx value here, that is 20.61 plus 10.61 square of that, finally we will have value 23.18 Newton. Then direction of that resultant is given by tan inverse sigma fy by sigma fx, which is equal to tan inverse 10.61 divided by 20.61, and that value is 27.24 degree. Mind well, this is with positive x-axis. Solving more problems. Now say this is one problem which in this case here instead of two forces there are more than two forces. Then also we can solve this problem by means of resolution method. So here four forces are given: this force, this force, this force and this force. All these are coplanar concurrent, and so first of all we will require to draw simplified figure, or we will show resolved components of all these forces. So here it is shown, or simplifying that values here in the form of components along x and y. So here 20 Newton force making angle 30 degree with x-axis, so its component along x will be 20 cos 30 and along y it will be 20 sin 30. For this force 25, it is totally in the y direction, so its x component will be 0 and y component will be full, that is 25 full. Here this is 30 Newton force which is making angle 45 degree with y axis, so its y component will be cos, which is written here 30 cos 45, and its x component will be 30 sin 45. Then component of this force along x and y, angle given with x axis, so it will be 35 cos 40 and along y it will be 35 sin 40. Then finding sigma fx value. So here sigma fx, and with this sign we will have summation of forces along x. So summarizing all these values, that is this value, this and this, so there are three values, and as per sign this will be plus, these two values will be minus. So here it is written 20 cos 30 minus 30 sin 45 minus 35 cos 40. So calculating this we will get minus 30.7 Newton. Then sigma fy, considering vertical upward sign is plus, and here you see in the x direction there are values 1, 2, 3, 4. So summarizing all these values with sign, three forces in the upward vertical direction, so these three forces are 30 cos 45, then 25, then 20 sin 30, and downward force, that is 35 sin 40. So calculating this we will get this value, that is 33.72 Newton. Then resultant is given by this equation, r is equal to root of sigma fx square plus sigma fy square. So putting value of sigma fx here, which is minus 30.7, so square of that, plus sigma fy, that is 33.72 square of that. So finally we will get value of r 45.60 Newton, and this is, mind well, it is the magnitude of resultant. Direction of resultant is given by alpha r, which is equal to tan inverse sigma fy by sigma fx, and tan inverse, putting that value 33.72 minus divided by minus 30.7, so we will get a value of alpha r minus 47.46 degree, and this is with positive, this is with the x-axis, but here it is minus, means it is value in the clockwise direction. And we can also see our sigma fx value is minus and sigma fy value is plus, so it will be falling in the second quadrant. That's why r is shown here, an angle with this x-axis, which is the nearest angle or acute angle, and that is nothing but 47.46 degree. Minus sign because it is measured in the second quadrant from negative x-axis in the clockwise direction. But say if you want to find out angle of this resultant force with respect to vertical axis, then what will you have to do? You will have to deduct this value of resultant force with x from 90 degree. So 90 minus this value will give you resultant with angle of resultant with y-axis. Then next problem, that is suppose you are given forces of 2, 4, 6 and 8 kilonewton respectively act on regular pentagon as shown in figure, and you are asked to find out resultant. Then you are given figure like this, which is pentagon, and forces are acting like this. So this is given in the figure. We can write forces acting on this point like this. So this is what force system is. So here along x, this is considering x-axis, that force is 8 kilonewton. Here with this axis, angle of 6 kilonewton is 36 degree. So using the geometry of regular pentagon, we can find angle internal and external, that is say 360 divided by 5 will give you value 72 degree, 108 degree, sorry, 108, and if you deduct that value from 180, then it will give you 72 degree. And here, so interior angle and exterior angle, which will be 108 of each. Knowing this geometry, we can write angles. So angle of this is 36 degree, angle of this is also 36, and here angle of this also 36, and this angle as 72. Now resolving these components, resolving these forces along x and y, we will get component of this force, that is full, which is 8 kilonewton, and cos component of this, that is 6 cos 36. Component of this force, 4 kilonewton force, that is 4 cos 72, because this angle is 36 plus 36, that is 72. And component of this force, which is falling in the second quadrant, so its component would be 2 cos 72, and vertical component as 2 sin 72. So then doing algebraic sum of components along x and y considering sine, we'll get along x sigma of x as 8 plus 6 cos 36 plus 4 cos 72 minus 2 cos 72, which is equal to 13.47 kilonewton. Sigma fy considering vertical upward sign plus, will have value 6 sin 36 plus 4 sin 72 plus 2 sin 72, which is equal to 9.23 kilonewton. Then r is root of sigma fx square plus sigma fy square. Putting values of sigma fx and fy here, we will have resultant 16.33 kilonewton. Then alpha r, that is direction of resultant, which is tan inverse of sigma fy and divided by sigma fx. So that angle will be coming 34.42 degree. Then locating this resultant and its value, its magnitude and direction, we can see sigma fx is plus value and sigma fy is a minus value. Sorry, it is also plus here. So it is falling in the first quadrant. So it can be shown like this. So this is known as location of the resultant force in the quadrant system. Then suppose the resultant of 4 forces is as shown in figure, and its resultant say is already given 26.7 Newton, and angle of that resultant is also given 30.6, and you are asked to find out force F and angle phi. So here this is force system given, in which forces 40 Newton, 20 Newton, 25 Newton, and force F here, which is unknown, and it is making angle phi with negative x-axis. And also resultant of all these forces is given, that is R is equal to 26.7 Newton, and alpha R, that is angle of that for resultant, is 30.6. Then to solve this problem, what we will do, first of all, we will find the resolved component of resultant, because resultant is already given and it is inclined with respect to positive x-axis. So component of resultant force will be along x, that is Rx, which is given as because it is in the x direction towards left, so minus 26.7 cos 30.6, so that value is coming as minus 22.98, and component of resultant R along y is minus 26.7 sine 30.6, so that is minus 13.59. Then also writing components of all the forces, 4 forces, we will have simplified figure as this. Okay, then doing summation of sigma, we finding value of sigma fx, we can write as sigma fx is equal to 20 cos 70 plus 40 cos 60 minus, because in the on the left side, so minus 25 cos 30 minus f cos phi is equal to minus 22.98. So finally we will get f cos phi value here, which is equal to 28.17 Newton, and sigma fy is equal to 20 sin 70 plus 25 sin 30 minus 40 sin 60 minus f sin phi, which is equal to 13.59. So from that we can find f sin phi is equal to 10.24 Newton. And solving this equation 1 and 2, or dividing this equation 2 by equation 1, we will get tan phi value. So phi will get from that 19.97, and f, putting that phi value in any equation, that is in equation 1 and 2, we will find f value, that is 29.98. So today we discuss resolution, finding resultant force using resolution method. We'll next time solve more problems on resolution, or say 1 or 2 problems on resolution, and then we'll see parallelogram law method next. So I think you have understand this as good, and I thank all. Okay, thank you.